Guys, so today we are going to be talking about exponent rules, okay? But before we talk about our exponent rules, I need to make sure that we feel good about some vocabulary. So, what we have, so we are going to be talking about some vocabulary today. So, the first thing I want you guys to write down is we have this 4x to the 5th, okay? And this 4, this represents our coefficient, right? This is the coefficient. So guys, this is some good vocabulary to make sure we feel really good about. That's the coefficient to our variable right here. And this x right here, this is your variable, but another word that we are going to use for this is the base, all right? So the x is your base, all right? And then last, but certainly not least, what does this little 5 represent, y'all? The exponents, okay? I want to make sure you guys feel good about the words that I use here today, okay? Your exponent is the little teeny number, and it also is called a power, right? So sometimes your exponent is called a power. So these are called exponent rules. They are also called power rules sometimes, all right, guys? So what I want to do is I want us to look at what it looks like to expand this little example right here. So if we were going to expand 4x to the 5th, if I wanted to write it in expanded form, we would write this as 4 times x times x times x times x. Are you guys comfortable with that? Why did I write x 5 times? Because it's x to the 5th. Are you guys comfortable with that? Awesome. If we wanted to expand something else, let's say 2x cubed y. Well, first of all, guys, we have a couple things going on. What is my coefficient in this case? 2, right? We have a 2, that's our coefficient. And then we actually have 2 different bases, don't we? We have x to the 3rd, right? So we have x to the 3rd. But then we have a different base, which is our y. Do you see that? We have another base, which is our y. And guys, what is the exponent on the y? It's really kind of like a little invisible 1 there, okay? So if there's no exponent, it's kind of like there's a little 1. So if we wanted to expand this little guy, how we would write this is we would write 2, and then we would say x times x times x, and then we would just leave our y. Are you guys comfortable with that? So that is the way that we would expand it. Now guys, typically when I write these problems, I do my variables in alphabetical order, right? I do x, y. If I had a and b, I would write A and B. I would not write BA, all right? So typically you keep your variables in that alphabetical order. But it's not incorrect if it's not, all right? Do you guys feel pretty good about that so far? About expanding it? So what we are going to do is we are going to use these expanded forms to come up with some rules, all right? So the first rule that we are going to come up with is the product rule, all right? And then sometimes, guys, this is also called multiplying your powers, all right? So it's the product rule. So this is when we are multiplying things together, all right? Now, here's the thing. We don't actually know what our product rule is. So I am going to skip a few little spots here, and I'm going to we're going to do some examples to see if we can create the product rule, all right? So I'm not going to tell you what the rule is yet. I want you guys to help me come up with the rule. So I'm going to give you guys some examples right here. Let's not skip numbers, Miss Humanek. 1, 2, 3. Okay? So my examples that I'm going to give you, we're going to do 4x squared times 2x cubed, and then y squared times 3y to the 4th. And then we're going to do 2x cubed y times 5xy squared. Okay? So we're going to do a few little examples right here, and we're going to see if we can come up with a product rule, our product of our powers here. All right? So what we're going to do is we are going to expand these. All right? So how would we expand these? I'm going to do different colors. For my coefficients, I'm always going to use pink here. So this is going to be 4, and then how would I write x squared here? X times x. Are you guys comfortable with that? And then for my second one, I would write times 2. And then how many x's do I have right here? 3. So that's going to be x times x times x. Are you guys comfortable with that so far? Awesome. So now, guys, if I wanted to simplify this, so I just expanded my two terms. Well, guys, what is 4 times 2? I'm sorry? 8. And then how many x's do I actually have? 1, 2, 3, 4, 5. So this is actually 8x to the 5th. Are you guys comfortable with that? Cool. Okay? So that is what it looks like in expanded form for this first one. So guys, I want you guys to do numbers 2 and 3 in expanded form, and then I want you to tell me what you guys get. So go ahead and do, I did number 1 for y'all. I want you guys to do numbers 2 and 3 in expanded form, and then we're going to kind of go over it together here, okay? Okay. Awesome. And then, so guys, what did we get as our answer to number 2 here? Can someone raise their hand for me? What'd you get, Will? Perfect. That is correct. 3y to the power of 6. And then what do we get as our answer to number 3 here? Anybody else? Any besides Will? Ooh, 10 to the power of 4 and y to the power of 3. Sorry, my 6 is a little bit grumpy looking, but we can deal with it. Okay? So so guys, these are our 2 answers from our expanded form. Do you guys feel good with that? Okay, so now that you guys are looking at these 3 examples, can you guys help me? Do we see any kind of rule or shortcut that we could do so we don't have to expand it out every single time? Do you guys see any kind of shortcut or rule, if you look at your exponents, you look at your numbers, is there anything that we can do? What do you see, Andrea? You add your exponents together. Look at that. So your x exponents, 2 and 3, 2 plus 3 is 5. Okay, what about your y's? 2 plus 4 is 6. There we go. And last but certainly not least here, ooh, this one's a little interesting on number 3. Well, guys, remember like I said, when you don't have an exponent, it's kind of like your exponent is 1. So, guys, 3 plus 1 is x to the 4. And y1 and y2, 1 plus 2 is y cubed. Okay, so we realize that we're adding our exponent. Excellent, excellent observation there, Andrea. Okay? And so, what we're going to do is I'm going to give you guys your rule. Okay? So when you are multiplying numbers with the same base. So guys, you noticed we kept the x's with the x's, the x's with the x's, the y's with the y's, right? When you're multiplying numbers with the same base, you keep the base and you add your exponents. So this is important. You keep your base and you add the exponents. But guys, here's my question. What did we do to our coefficients? Did we add up the coefficients? No, what did we do to our coefficients? We still multiplied our coefficients. So 4 times 2 was 8. 3 times, I guess that coefficient is just 1, is 3. 2 times 5 is 10. So over here on the side, guys, I want you to write that you multiply your coefficients, right? Whoops, forgot the S there. There we go. Okay? So you multiply your coefficients. Ugh, that's going to drive me nuts. All right? Do you guys feel good about that? There we go. That was a little better. So you're going to multiply those coefficients. And so the way this looks on your formula chart, because you actually do have this stuff on your formula chart, the way this looks is they say a to the m power times a to the n power is a m plus n. So they're telling us that when you multiply your powers, you add your exponents. Do you guys feel good about that? You multiply your coefficients, but you add your exponents. So this is the way the rule looks on your reference sheet. Okay? So what I'm going to do is I'm going to give you guys a couple of examples, and I want you guys to practice using that rule where we add the exponents together instead of expanding it out, because we don't really want to take up all that space every single time. So here we go. For number 4, we're going to say x squared y to the 4th times x cubed y to the 5th. So this one doesn't have any coefficients, all right? And then I'm going to do number 5 over here. And we're going to do negative 4x to the 7th y to the 6th times 11 x to the 5th y. All right? So guys, I want you guys to do a couple of these examples, and then I want you guys to practice doing them kind of on your own here, okay? And so see if you can do these guys, and then you're going to check yourself against me, okay? got all these examples up here for you. I'll go ahead and do numbers 4 and 5 with you, okay? So let's check this out. We don't have any coefficients to multiply, so we don't have to worry about that. But we do have our x squared and our x third. So guys, what we do is we say, okay, x 2 plus 3. Which, what is that really going to simplify to, y'all? That's going to be x to the 5th, right? And then for my y's, we have y to the 4th and y to the 5th. So that's y 4 plus 5, which is really y to the 9th. So our final answer here is x to the 5th, y to the 9th. Now guys, I'm going to be super honest. I basically never write this step down, okay? I don't sit here and do x 2 plus 3. I do the 2 plus the 3 in my head. Does that make sense, y'all? But I wanted to write it down this one time, or these couple times, so that you guys could see what I'm thinking in my head when I do it. Because x squared times x to the third is really x to the 2 plus the 3, which is x to the 5th. All right? So we are adding our exponents together when we're multiplying across like this. All right? Now, let's go and do number 5. Now we have some coefficients, don't we? So guys, what do we do with our coefficients when we're multiplying them together here? We multiply them. So we're going to say negative 4 times 11, okay, which is going to be what? Negative 44. Like I said, I do this one in my head, okay, guys? You don't have to do that one. You don't have to write that one down. And then we do x to the 7th times x to the 5th. Well, that's x to the 7 plus 5, which is going to be x to the 12th. And last, but certainly not least, we do our y's. Y to the 6th. Uh-oh, what's the exponent for this guy right here?
1.
It's like a 1. So that's y to the 6th plus 1. So that's y to the 7th. So my final answer would be negative 44, x to the 12th, y to the 7th. Do y'all feel good about that? So we are just multiplying our coefficients and adding our exponents. So on this one right here, I'm just going to multiply them across here. So that's what? Negative 5 times negative 8. So that's going to be a positive 40. All right? And then x to the 3rd times x to the 4th. What do we do with our exponents here? We add them up. So that's going to be x to the 7th. And last but certainly not least, y to the 7th and y squared is going to be y to the 9th. All right, y'all? So this right here would be our final answer. 40x to the 7th, y to the 9th. And for our last little guy right here, of course, we have some fractions. So we have 1/2 times negative 2/3. Well, guys, what is that going to be, y'all? So 1/2 times negative 2/3, that's going to be negative 2 over 6. Well, is that going to reduce, y'all? Is that going to reduce? Yeah, it's really going to be negative 1/3, right? So I'm going to kind of do this down here. Negative 1/3. So that's going to reduce down to negative 1/3. Then we have our x's. X to the 1 times x to the 5th gives us x to the 6th. Are you guys cool with that? And then we have y squared and y 6th. So that's y to the 8th. So this right here would be negative 1/3 x to the 6th, y to the 8th. Another way that you might see this little guy written is you might see it as negative x to the 6th, y to the 8th over 3, where they kind of multiply that 1/3 in. You might see it this way as well. I just want to show y'all. You could technically write it both ways. Okay? Negative x to the 6th, y to the 8th over 3. All right, y'all? You guys feel good about this so far? So what's our power rule? Can you guys say it in your own words? You don't have to use this. The product of powers, or the product of our power rule. What's a way that you guys can say that? Anybody? Add your exponents and multiply your coefficients. It's also up here on the board for you. I have it with multiply your coefficients and add your exponents. Another teacher likes to say, multiply the big numbers, add the small numbers, okay? That's totally fine. I just want to use the correct vocabulary here. We want to add our exponents and multiply our coefficients. Do y'all feel good about that? So that is our product rule. All right, guys? So next, we are going to jump to our next rule, which is going to be our quotient rule. All right, guys? So on the top of your paper right here, you guys can go ahead and write. We are going to come up with a quotient rule for our next one. All right, guys? We're going to come up with a nice little quotient rule. I'm going to give myself some nice good space here. I'm going to give myself 3 or 4 lines. And then I'm going to start with my number 1. Okay? We're going to come up with a good quotient rule. So, guys, quotient, what does that usually mean? Dividing. So now we're going to be dealing with some division. Okay? So we have 8x to the 4th over 2x squared. That's going to be my first one. My second example is going to be 9y to the 5th over y. And my last example here is going to be 8x squared y to the 6th over 10x to the 5th y squared. All right, guys, y'all feel good about those? So, Finn, I changed that one a little bit, okay? It was x to the 3rd on the other day. Okay? So, guys, y'all feel good about these right here, these 3 little examples. So what we're going to do is we are going to expand these examples out, all right? So how we're going to expand them is we're going to expand them with our x's and our y's and all that good stuff. So I'm going to write this one out with some expansion. I'm going to go ahead and give myself a little space on my line here. And guys, my 8 is my coefficient. And then how do I expand the x to the 4th? I do x times x times x times x. My line wasn't quite long enough. There we go. And then on the bottom here, I have my coefficient of 2. And then I have my 2 x's because it is x squared. Do you guys feel good about that expansion? Y'all feel good about that so far? Cool. So now we are going to simplify this. Well, guys, how can we simplify 8 divided by 2? How can we simplify that? Yeah, well, they're both divisible by what? 2. So this would simplify into 4, and that would simplify into 1. Do you guys feel good about that? So we're going to make it 4 over 1, or just 4. Okay, and then with our x's, guys, we are going to cancel out terms that are exactly the same. So we can cancel out those x's right there. So what are we left with, guys? Just 2 x's, and they're only on the top, so it's just 4x squared. So if we wanted to actually write out our equation, or our little guy right here, it would be 4x squared. And that would be our final answer, because 4x squared over 1 is really just 4x squared. Are you guys comfortable with that? Okay, so we have 4x squared. Now, I want you guys to do the same thing. I want you guys to expand numbers 2 and numbers 3 and see if you guys can come up with if you guys can recognize any sort of pattern. All right, guys? So let's see what we do. I want you guys to expand numbers 2 and number 3 and see if you guys can come up with any kind of pattern. I'm going to do the same thing for you guys here. Alright, so I'm expanding number 2. This is what the expanded form looks like. And then I'm also going to expand number 3. I want you guys to actually do the simplifying here on your own. Awesome. All right. So guys, how could we simplify number 2? These are both the expanded forms. How can we simplify number 2 here, y'all? Does anything cancel? Can we simplify our coefficients, or is it just kind of the same? It's really just 9. That's cool. Okay? And then what happens to our y's here, y'all? What happens? Does anything cancel out? Yeah, these guys cancel out. Do y'all feel good about that? So how many y's are we left with? 1, 2, 3, 4. So what is going to be my final answer here, y'all? And it's really kind of like it's over a 1 because there's nothing left. So my final answer is just 9y to the 4th. You guys comfortable with that? Cool. All right. Now let's take a look at this guy. So how can we simplify 8 and 10, y'all? How will that simplify? What will that simplify into, y'all? What kind of fraction? There we go. Thank you, Sophia. So that would be 4 over 5. So we have a 4 and a 5 right here. And then, let's hear, what happens to our x's? Do we have anything that cancels? Those two guys. So where do my x's end up, y'all? They're going to be, well, down here, x to the 3rd. Are you guys comfortable with that? And then, ooh, I'm going to cancel out this y and this y. So how many y's do I have left? Y to the 4th. So we have 4y to the 4th over 5x to the 3rd. Okay? So I guess I could rewrite it if I really wanted to. But I don't really need to, actually. So it already looks pretty good. I don't need to simplify it any further. So I'm just going to write it as such. Are you guys cool with that? All right. So do you guys notice any patterns? Is there any kind of pattern that we recognize in this quotient rule here? What do you recognize? Anything? We subtract the exponents now. Okay? So guys, check it out. So 4 minus 2 was 2. 5 minus, remember that really is like it has an exponent of 1. 5 minus 1 is 4. Now number 3 is kind of interesting, y'all, because we subtracted our exponents, but where did the x end up? On the bottom. Because our larger exponents was on the bottom. So I kind of like to think, because 5 minus 2 is 3, which is where we got that x to the 3rd. But guys, I like to think it's kind of like the heavyweight, all right? So like wherever the bigger exponent is, it like pulls it to wherever it is. So because my bigger exponent for number 1 was on top, it pulled it up on top. Because my bigger exponent for number 2 was on top, it pulled it to the top. For number 3, my bigger exponent was on the bottom. So it pulled it to the bottom for x. For our y variables, where's the bigger exponent? On the top. So it pulled it up to give it y to the 4th. Does that make sense? So it kind of pulls it up wherever it's at. So if we are going to write our quotient rule kind of officially here, what we're going to say is we're going to say when dividing numbers with the same base, keep the base, and now we subtract our exponents. All right, guys, when we multiplied numbers, we added our exponents. They're both kind of positive things. When we divided numbers, we subtracted our exponents. They're both negative things. But guys, what did we do to our coefficients? What did we do here? We divided them, or we simplified them, didn't we? So guys, the term that I like to use is I like to say that you have to simplify your coefficients. Okay? If you want to use the word divide, that's okay too. But guys, we need to simplify our coefficients. And so the way this rule looks officially on your little reference chart is it says a over to the m power over a to the n power is a to the m minus n. All right, guys, that's the way it looks officially on your little reference chart. A to the m over a to the n equals a to the m minus n. Y'all feel good about that? Okay, so let's do a few examples together. Now that we have come up with a rule where we subtract our exponents, let's do a few examples together. All right, so I'm going to give you guys a few little examples here. So let's take a look at this. So we are going to do, oops, I want to do black, not blue. So we're going to look at number 4 here. So I'm going to say this is 12x to the 5th over 9x to the 8th. I'm going to do number 5. Negative 5x cubed y squared over negative 10x to the 1. Oops, x. That was supposed to just be an x, but you can put a little x1 there if you want. X to the 1, y to the 5th. All right, guys, so I want you guys to do these 2 problems kind of on your own right now. See if you can use the rule and apply the rule that we have. All right, guys, see if you can use that rule and apply it real quick. All right, guys, so let's do numbers 4 and 5 together. Okay, so I know you guys have already worked on these a little bit. So what the first thing we want to do, guys, is we want to simplify our coefficients. So how can we simplify the 12 and the 9? What is that going to reduce down to? 4 and 3, yeah. So this is going to be 4 over 3. Are you guys comfortable with that? And then the x to the 5th and the x to the 8th. Well, guys, where's your bigger exponent? On the bottom. So that means my x is going to end up on the bottom. And 8 minus 5 is 3. So I personally don't think that looks super great, so I'm going to go ahead and rewrite it because I like my little numbers to be all centered. So I would rewrite this as 4 over 3 x to the 3rd. You do not have to do that. That is simply a little preference thing. I would kind of rewrite it so that it looked a little bit neater because I like them to be centered. But you guys don't have to, okay? But when I go straight across here, I like to do my coefficients, then I like to do my x's, then I like to do my y's. So let's look at this guy. Let's look at our coefficients here. Negative 5 over negative 10. So how is that going to simplify, y'all? That's going to be a positive 1 over a positive 2. Because a negative over a negative makes a positive. Do you guys feel good about that? Okay, now let's take a look at our x's. My x value, x to the 3rd, and then that is just x to the 1. So where's my bigger exponent here? On the top. So it's going to be x squared, because 3 minus 2 is 1. 3 minus 1 is 2. Okay, then we're going to look at our y's. Where's my bigger exponent? It's on the bottom. And 5 minus 2 is 3. Now that one doesn't look so bad, right? But I would go ahead and rewrite this without the 1 on the top. So how I would write this is I would actually write this as x squared over 2y cubed. So this is kind of how I would write my final answer. If you decide to put the 1 on the top, that's okay. But I just like to drop those understood ones. Okay, so it would be x squared over 2y cubed. Y'all feel good about this so far? All right, can someone walk me through number 6? Let's see here, Finn. Okay, you can do some talking. All right, so let's walk me through number 6 here. So how are my 3 and my negative 18 going to simplify here?
So you divide 3 negative 18 to get
Negative 1 over 6. Could I also have done 1 over negative 6? Sure, that would have been fine. But I kind of like to keep my negatives up there. So we do negative 1 over 6. Perfect. And then what are we going to do with our x's here, Finn?
so when you subtract them, you're going to x cross each other out.
Yeah, because it's x cubed over x cubed. And remember, the exact same thing over itself is going to cancel. So do we have any x's over here? No. All right. And then last but certainly not least, we have y to the 1 over y cubed. So which one's bigger, Finn? So where are my y's going to end up?
On the bottom.
On the bottom. Excellent. Excellent. And what is my exponent going to be there?
Y to the power.
Yes, y to the power of 2, because 3 minus 1 is 2. So if I was going to rewrite this and make it look a little bit prettier, like I said before, you don't really have to, but I just like to negative 1 over 6y squared. Like I said, you don't have to, but I just like my numbers to be all centered and pretty to make it look a little bit nicer. All right, you guys feel good about that? All right, last one here. This one's nice, all right? So let's take a look here. So what is if we are going to reduce, excellent job, Finn. Thank you so much. All right, so if we're going to reduce this, Ava, can you help me out here? How are we going to reduce negative 14 to negative 7? What is that going to reduce to? 2 over 1. Exactly. All right, and then for my x's, what's going to happen here? There's going to be 1 x on the top because my 5 is bigger than my 4. So it's kind of like it's x to the 1, right? And then what happens to my y's? They cancel out. So we're done. So I drew my line way too long there. So I'm going to go ahead and rewrite this guy. So do I really need the 1 on the bottom, y'all? No. So this guy just simplifies into 2x. We want to write this in the most simplified terms. Do y'all feel good about that? So product rule, we multiply our coefficients, add the exponents. Quotient rule, we simplify those coefficients, and then we subtract the exponents. Do y'all feel good about those rules right there? Excellent. All right, we are going to do our last rule today, okay? I know I'm going through them kind of slow, but I want us to feel really good about these, okay? All right, so our last rule is the power to a power rule. All right, guys? So our last rule is power to a power. Okay? Oh, yes. So we don't know what the rule is. We're going to leave some space here. We're not exactly sure what the rule is. So I'm going to leave like 3 little lines. And I'm going to do a nice little example here, okay? So our power to a power rule. So guys, we are going to be now raising things to a power. So I'm going to say this is 5x squared, y to the 4th, raised up to the 3rd power. Number 2, I'm going to write 2x cubed, y, and we're going to raise that to the 4th power. And for number 3 here, I'm going to use a lovely little fraction. We're going to say x cubed y over 3, and we're going to raise that to a 2nd power. All right, guys? So we're going to see if we can come up with a little shortcut here for our power to a power. So here we go. So what I want us to do is, guys, I'm going to write this little one as an expansion. Okay? So instead of 5x squared y to the 4th raised to the 3rd power, I'm going to write this 5x squared y to the 4th, 5x squared y to the 4th, 5x squared y to the 4th. Why would I do that? Why would I write it 3 times? What do you see, Andre? Because it's raised to the 3rd power. That exponent is outside of the parentheses. So everything inside my parentheses, I do 3 times. All right? If my 5 wasn't inside the parentheses, we wouldn't have done the 5 3 times. Okay? But because we do everything in the parentheses 3 times. All right? So now let's use our product of power rules, our product rule here, to see what we get. Well, guys, what's 5 times 5 times 5? What is that going to be? 125. Do we feel good about that? All right. Now, what is x squared times x squared times x squared? Well, we're going to do 2 plus 2 plus 2, so that's going to be x to the 6th. Y'all feel good so far? And then our y's, y to the 4th, y to the 4th, y to the 4th, that's going to be y to the 12th. So our final answer here is 125, x to the 6th, y to the 12th. Feeling good? All right, so what I want you guys to do is I want you guys to come up, see what you can do for numbers 2 and number 3. I want you guys to expand it and then see if you can come up with a rule. All right? So expand each one of these and then simplify them and see if you can come up with a rule that makes sense here. A little shortcut. What is something that it follows every single time? So I kind of expanded it for y'all, but I want you guys to kind of come up with a rule or a shortcut for these. All right. Do you guys notice any kind of pattern that we could do here? Any kind of shortcut rather than having to write it out 4 times or write it out 3 times? Andrea, what do you see? Yes, you multiply the exponent on the outside of the parentheses by the exponent on the inside of the parentheses. The way someone said it in another class is it's like you're distributing your exponent, right? And guys, there's parentheses, and you always distribute when you see parentheses, so it's kind of nice, right? So yes, you multiply your exponents together. Because just like Andrea noticed here, 3 times 2 is 6. And 3 times 4 is 12. Here, 4 times 3 was 12. And the y, it's kind of like there's a little 1. 4 times 1 is 4. And guys, it doesn't matter if it's on the top or the bottom. We're still going to do it. 3 times 2 was 6 again. And 2 times 1 was 2. All right, guys, so we're multiplying our exponents now instead of adding our exponents. But what did you guys notice about the coefficients? Did we multiply the exponent by the coefficient? Did we do 3 times 5? Is that what we got? No. What did we do to the coefficients there? Yes, we did 5 to the power of 3. We raised the coefficient to the power. And the reason why, I want you guys to kind of see this. It's kind of like the 5 has an exponent of 1. So you were still saying 5 to the power of 3. Here, we said 2 to the power of 4. And then down here, we said 3 to the power of 2. Because it's like we're multiplying the 2 by the 1 there. All right, guys? So the rule that we come up with for the power to power rule is when a power is raised to another power, keep the base and multiply your exponents. Okay? But our little caveat, we got to talk about our coefficients here. But you raise the coefficient, to the power. All right, guys, you raise that coefficient to the power. So the way this rule looks on our little reference charts is a to the m raised to the n power is equal to a to the m times n. And guys, we do this for each thing inside your parentheses. It doesn't matter if it's got division or anything, you do it to everything inside the parentheses. If it's not in the parentheses, you don't raise it. But if it is in the parentheses, then you raise it. All right, guys? So we're going to do a few more examples, and then I want to give you guys some time to get to work on your homework, okay? So I'm going to write these lovely little examples for you guys, okay? So we have negative 3x to the 5th power y squared. And then we are going to raise that up to the 2nd power. All right, y'all? We're going to raise that up to the 2nd power here. And then for number 5 here, I'm going to mix things up. And I'm going to do 7x to the 5th power over 4y to the cubed power. And I'm going to raise that all to the 3rd power. All right, guys? So I want to do that one with you guys here. All right? And then I'm going to give myself five little spaces here. Okay? For number 6, I'm actually going to do the exact same thing as number 4, but instead of raising it to the 2nd power, I'm going to raise it to the 3rd power. So negative 3x to the 5th y squared, all raised to the 3rd power. And then for number 7, our last little problem here, it's not going to be the same. I'm going to do it different. Negative 2x squared over 3y cubed raised up to the 4th power. All right, guys, so these are going to be the examples we follow, and we are going to try to do it using our power rules here. All right, we're going to try to do this using our little power rules. All right, so I'm going to do number 4 and number 5 with y'all, okay? So here we go. So for number 4, the first thing I like to do is we want to raise our coefficient to the power. So this is going to be negative 3 to the 2nd power. And guys, I'm going to tell y'all something. Anytime you have a negative number, go ahead and put it in parentheses. It's going to get really grumpy with you if you try to... The calculator gets really grumpy when you do a negative number without a parentheses with exponents, okay? So just get practice of putting it in the parentheses. And then we're going to do x to the 5 times 2. So what is my exponent for my x going to be? 10. And then we're going to do y to the 2 times 2. So that's going to be y to the 4th. All right? And then we want to go ahead and simplify this. So negative 3 squared, what is that going to give me? It's going to give me a positive 9 x to the 10th y to the 4th. So our final answer is positive 9 x to the 10th y to the 4th for that number 4 here. Now what I want to show you guys here is this is where it gets a little bit wonky. If you do it with the parentheses like I recommended here, then it gives you that positive 9. But if you do it without the parentheses, negative 3 squared, it gives you the wrong answer. I feel like our calculators are really smart with a lot of things, but with negative numbers, they're just dumb, okay? they can't figure out the difference between a negative sign, a positive sign, or negative sign and a minus sign. It's super annoying. But guys, make sure you put it in that parentheses so you get the right answer. You don't want to do it without the parentheses. Okay? All right. So that's number 4. So let's look at number 5 together here. So we're going to go ahead and I'm going to go ahead and give myself that 7, that exponent of 1 there. So this is going to be 7 cubed. All right, 7 to the 3rd power. And then x to the what power? To the 15th power. And then we are going to go ahead and now we're going to do our bottom, our denominator down here. So we are going to do 4. We're going to take our 3 and we're going to distribute it down here. So that's going to be 4 to the 3rd power. And then this 3 we're also going to do to the y. So that becomes y to the 9th. Do y'all feel good with that? So then we go here. And what is 7 cubed? Can anyone do that in their calculator for me? Or do you just know it off the top of your head? Anybody know 7 cubed? 343. Yes, sir. So that's going to be 343. X to the 15th over 4 cubed is going to be 4 times 4 times 4, which is 64 over y to the 9th. How do you guys feel about these guys so far? Now, I would go ahead, guys, and double check and make sure that 343 over 64 doesn't simplify. So I do 343 divided by 64, go math, enter. I still get the exact same fraction, 343 over 64. So make sure your fractions don't simplify. Make sure you don't need to simplify any x's or y's, and you're good to go. Does that make sense, y'all? So you apply that power to everything inside of your parentheses. All right, y'all? How do you guys feel about this so far? Yeah? Okay. So what I want you guys to do is... All right, guys. So if you want to check your answers here for number 6 and 7, you guys can see the way that we kind of distributed. We raised each thing inside that parentheses to the power. And when we have 2 exponents, we multiply the exponents together, or we just simply raise it to that power. All right, guys, y'all feel good about that? Awesome. I'll go ahead and leave those up there on the board for y'all.